Good morning and welcome to Race Industry Now, the weekly webinar series from ePowerTrade, presented to you by ARP, Performance Plus Global Logistics, PIC, Ferrea Racing Components, and Fifth Third Bank Motorsport. I am Francisque Savignan, the founder and CEO of ePowerTrade, the racing industry, every minute, every day. This is episode 442, and we're going to be talking coatings with line-to-line coatings. With me this morning are Judy King, the co-founder of ePowerTrade, and our superstar host, Mr. Jeff Hammond. Judy?
Thank you, Francisque, and thank you, everyone, for joining us today. I just wanted to say that these past few weeks, we have had so many buyers reaching out to suppliers, just like a trade show. And it's been great to see. And what I could share with you is, I promise, I've been doing this for 25 years. You're going to see companies on this platform you've never seen before. So if you haven't signed in and used it, please do. It's absolutely free. It's just like having a badge at a show. So I'm just excited about all the excitement on the platform. Jeff?
Well, I'm excited to hear that for you and Francis and everybody out there in our racing world around the globe, that we continue to grow and provide great service and great information to everybody who is a part of it. And I think the thing is, Francis, you say I'm the superstar. I think these gentlemen that are coming on now have got a superstar product, and I'm really interested to see exactly how it works and the benefits it can bring a lot of our consumers and competitors.
Absolutely. So I see Andy, Mark, and Woody on. So why don't you carry on, Jeff?
All right. Thank you, sir. Excuse me. Good morning, gentlemen. How are we doing?
Good morning.
Good. So, Andy, had a chance to talk to you a little bit yesterday afternoon, and, really excited about being a part of this today. How about, let's break it down. I mean, tell me about APC and this coating that you guys have come up with. Explain to me a little bit the beginning of it and where we're headed with it.
Yeah, well, back in the day, we started a company called Flow Coatings, and that was to address a tier one automotive manufacturer's need to seal up superchargers. And once that was rolling, we started branching out into other components, automotive, and here we are today doing lots of different components. And along the road, Mark Gelstein, he joined us in about 2012, and Woody in about 2015 or so. And we've had a great time addressing the growth of this product.
Well, guys, when you talk about what I've been able to learn, I guess it'd be easier to me to say, what do you not coat? Because I see pistons, valves, stems, oil pumps, casting, lifter bores. I mean, it seems like, you've got from A to Z that your product works on. So why? I mean, what does APC, and what does APC stand for, in layman's terms?
APC stands for abradable powder coatings, and abradable coatings were a revolutionary idea that made jet engines practical. Abradable coatings are used in jet engines to safely seal the tips of the turbine against the housing, but being aerospace, it's kind of an expensive process. As Andy said, we borrowed the idea in 2000 and came up with a low-cost, affordable way to offer the same abradable sealing benefits through powder coating. And as he mentioned, we started on automotive superchargers, and then we've branched out to other applications from there.
So, Woody, what has the benefits, or what is the combination of you guys coming together? What does it do for the automotive industry, specifically?
Well, one of the best examples, Jeff, is our piston skirt coatings. Back in the early 70s, I built race engines in the Can-Am series. You might recall that series. Pretty exciting, all dominated by big block 492 and 510 big block Chevys. we had piston scuffing issues back then. I think you can find them even still today across most racing venues. This coating applied to a piston skirt basically starts to mitigate that problem and can make it completely disappear. We were stuck with using the piston to wall clearance that a manufacturer might recommend to us, might be up to 5 or 6 thousandths. We didn't have any way to control that. Now with these coatings, we apply that abradable powder coating to the surface of both piston skirt, the thrust and anti-thrust piston skirts. And as this self-fits, we end up with a maximum allowable clearance as that piston heats up and expands in the bore. It does a lot of things, keeps the piston stable in the bore, increased ring life, and durability of the piston is some of our customers have used pistons for 2 and 3 events, and we'll show you a good example of this. One of the classic examples we like to have, we use at PRI the last couple of years. This is a Trans Am 2 piston. This piston ran in 4 full race events, won 3 of them. So they weren't just out there driving around. And the Total Seal guys took a look at the piston rings on here and said, you can run them again. They're still good. That's a testimony to the bore, the stability this piston is going to have in the bore. And we'll show you in the next coming slides, we'll show you how we do it, what the Strybeck fitting curve is and how it applies, and just exactly how this actually works in the engine.
All right, Andy, we laid the groundwork. How about you guys take the ball right now and run with it and show me what all this here really means to all of us out there in the industry, because I love what I've read. I love what you guys are saying about what it allows you to do is to make your product better and extend life already right on the get-go. So there's got to be a power benefit here somewhere along the way. So I can't wait to hear the rest.
Yeah, okay. So I got to get my PowerPoint here going and then do the slideshow. So, okay, we've got a lot of slides. I'm going to go pretty quick. Thanks a lot for taking the time to join us. These are some of the applications we deal with. The biggest thing is we control the clearances between running parts. So we put this coating on, and if you were looking at a 2-dimensional cross section, you see these peaks here and valleys. When you measure your parts, they're going to measure, on some of these top peaks. You start to run your device, assemble it. You might crunch some of those peaks. Then you start to run it, and the peaks pretty quickly wear down until they reach an equilibrium where you've got plateaus on the top, and still we like to have some of these gaps. If there's more abrasion to take place, that gives the material a place to go. It also, in an oiled application, gives you oil retention. So this is kind of a busy slide, but on the left, you can see this is kind of lumpy and fuzzy. That would be an as sprayed texture after we cure it. And then when you start to run it, those plateaus, the light gray areas are the plateaus left. And you've got the plateaus really polish up nicely. And each little plateau, if there's a different angle on the mating part, it will adjust itself to mimic the mating part. In an oiled application, this creates thousands of oil wedges because you've got this nice polished plateau and oil pockets to feed the oil wedge on each one.
If I could, Andy, that's one of the key elements to remember as we progress here with this coating. Heretofore, you had an oil retention in the crosshatch of your bore. You could calculate the volumetric oil capacity of what that is by depth of scratch. Now you have it on the piston skirt. So you carry a hydrodynamic oil layer trapped in those small pockets that Andy just mentioned, and it mates to the surface of the bore.
Yeah, and this is a slide that I really love talking about. You can kind of get lost in it, but this is the Strybeck equation. And if you can see my mouse cursor here, this is like the friction when you get a very thin oil film, you can see the coefficient of friction goes up. This over here, if you pinch all your oil out, you can scuff components. Over here, you've got a lot of clearance and you're actually stirring a lot of oil that never carries a load. So we really always want to be in this middle part for lowest friction. That's the Strybeck curve. Then Ian Hutchings measured all these different materials and came up with, hey, if you're over here at a low oil film thickness, you're going to have a high rate of wear. And if you're way out here with tons of extra oil and a space between your parts, there's no wear. So what we do with the graphite fuzzy soft coating is you build it too tight. We know we're going to pinch the oil out. And when we start operating this thing, it's going to create wear pretty quickly. But then as you continue to wear, your oil film thickens compared to the roughness. And then magically you pop out the bottom of this wear envelope and the wear actually stops. So look where the wear stops in the low friction area of your Strybeck curve. So this is basically the micro mechanism that allows these, like in the case of a piston, it will machine itself to fit. And when that oil film forms perfectly right here, you basically, the wear stops, you lock in the perfect geometry for that bore. And each spot on the piston skirt is going to go through that same process. So you're basically making your whole piston skirt on both sides of the piston fit the bore ideally without any extra clearance. So now that you've got the perfect oil film and the size is locked in, you've also got the largest possible piston in that bore. And so the coating has taken up what we call the integrated skirt clearance. You know, you measure those two gauge points and you know, the rest of the piston can rotate all around that and rattle around, and your rings, of course, are trying to follow that. So if you create less clearance between there safely and without adding friction, your rings stay true to the bore, then they keep the fire in the top, they keep the oil in the bottom, everything gets better. Wear reduces, lots of benefits. So that's basically the meat of what our stuff does. It kind of does the same thing in an unoiled environment. The parts are usually guided by, for example, on a supercharger, there's gears that time them. So you don't need the oil film to hold the parts apart and create the shape, but the gearing, once you spin it and it goes through its full thermal cycle, these parts will arrive at a equilibrium size where everything's happy, you got less gap, higher efficiency, and long life. So that's kind of the meat of what our coatings do, and it's fun applying them all over the place in mechanical devices.
Well, looking at what you're explaining here, you coat the piston. Let's just use piston for example. You coat it, you put it in the engine. When you fire it up, I mean, do you fire it up and how long do you let it run at, say, low RPM? And then when is there a process to break it in as far as that's concerned? And I think the other part of the question would be, if I'm doing alcohol engine versus a diesel engine, you know what I'm saying? How much does that change on different products that we run into?
Great question. Who wants to take this one, guys?
Well, I think in terms of the break-in process, I'll defer to Woody, but in terms of fuel, we've put the coatings on pistons that have been in every type of fuel you've got out there: gasoline, diesel, methanol, nitromethane, even various blends. So it's really been successful in all of those. We really are able to use the same formulation across the board, and it seems to be very happy in all those environments.
Yeah, Jeff, when we have customers, especially new customers call, those are a number of the things that we want to find out right off the bat. What are you running? Is it a gasoline engine application, alcohol, etc.? Even in street performance engines. So we got a little bit of a deviation for all of those things. But fundamentally, we want to expand that piston. We want to get it hot. And to do that, we need to load it. If we're in a dynamometer environment, that's really the easiest and simplest one to do, where we're going to fire it up and maybe put 25 foot-pounds of torque on it as a light break-in, get that engine up to temperature and shut it off and let it get completely cold. And then repeat the process at a little higher load, etc. At about 3 of those cycles, we're going to find ourselves pretty close to the end. But if we back up, and again, once we've determined which of these engine applications, which performance application we're looking at, that's where we're going to recommend what clearance to start with going forward. Okay, we might say, let's assemble this engine. For example, I'll put street performance engines together at 1.5 to 2 thousandths measured piston to wall. Okay, I'll fit the pistons by hand. I can feel what's going on in there. We'll measure it. We got 1.5 to 2. I'm ready to go fire it up and let it start abrading and finding the fit. In other applications for our top fuel customers, we don't know because they don't tell us, and that's okay. That's a horse of a different color anyway, but fundamentally that's what we want to do. We do talk to a lot of folks that don't have access to a dynamometer, and in a street performance environment, and that may be one of the more difficult ones to handle, and the one you need to be a little bit more careful with. And I've got a nice little hill out back of my place, and I can drive up that thing and get up to the top, and that's kind of a poor man's dynamometer, if you know what I'm talking about there.
Mhm.
But that's the idea. We want to go through the number of break-in cycles that are going to get that piston hot and get that expansion to the point, piston and bore, and find out what it's going to be in its final fit. In the future, if that engine ran and somehow got a little bit higher than it had ever been before, it'll go back and refit to that configuration. So you'll be fit to the highest thermal load, and combination of all of your components.
Yeah, so I've got a graphic. I think it might help to just skip ahead, because the break-in is a really common question. So this graphic shows, you build your engine, you do your regular heat cycles, leak checks. You may have to wear in your cam, your flat tappet lifters, do all that normal stuff. And
Right.
then, and this could include shutting it down ice cold and all that. But when you start to exercise the engine, we want to, when you load the piston, load the engine, the pistons are going to get hot quicker than the bores. So we want to apply some load and some heat, make the graphite hit the bores and start to wear off where it gets tight. And then, we're not going to full power here. We're going maybe 30% power, and then let it idle for a while. That's going to let your pistons shrink, and the oil's going to get back up in there. And then you go up to a higher loading scenario, and maybe for a little longer. And then you go back down and let it idle. So we want to keep hitting the bore with the graphite, but once it does for a few seconds or 15 seconds, whatever, we want you to let off and let that oil get back up in there. So you just kind of progressively climb your power curve until you can leave it wide open all day at full throttle. And once you start getting up in here, all your pistons are going to be the perfect shape for that bore. Now, remember, when we put it together, it might have called for 5 thousandths of clearance. We might have taken 4 thousandths of clearance up with the coating. So you got 1 thousandth of clearance on your brand new engine here. It's not enough. You've got to take a little bit of time to shed that extra graphite to find the right fit. So, and it's really a philosophy. You'll notice on this graph, it says power under RPM. It doesn't have, it's really a percentage of your power. And the time scale here, it's completely different for a street car than it is for a top fuel dragster. So it's really a philosophy. You want to just kind of keep pushing the power, let off, push it harder, let off, push it harder. And like circle track guys on a hot lap, their first couple hot laps, they'll feel the engine open up. They'll actually, man, I could feel it getting looser. And man, after a few hot laps, they go, God, that thing's smooth and awesome. So, you know, it's minutes to seconds where all this happens. And it could be an hour in a, you know, if you're running it real easy, it takes a while to wear in the coating. So that's a great question. And it always leads to, well, that's our most common question that we get here. And I don't know why I'm trying to arrow up. So I'll arrow back up here. And so, yeah, anyway, this might help as well. You know, when you buy a piston, your skirt basically has a proud spot in the center. And, you know, this is where you would see the scratches form on an uncoated piston. Well, we're going to coat the whole skirt over and just make this red spot even tighter. But then when that graphite comes off that red spot, the load is spreading out over this yellow spot better. And after a full break-in, you've got a large area with a perfect oil film based on that Strybeck fitting. And now you've taken away a lot of clearance and created an ideal oil film in a large area. So that's the magic of because then you're running the tightest piston with the best oil film. Your rings love it. Alcohol applications, you mentioned that. You know, if your piston is wobbling and you're spraying a lot of alcohol, it gets past and wrecks your oil film. Well, if you stabilize that piston and the rings, you're going to have less alcohol getting past those rings. You're also going to have the porosity content in the coating, providing more oil to that interface. So it's kind of a double protection against alcohol engines that tend to scratch up bores really bad. So
all of that right there. Yep. And one other thing real quick before we move on, because it pertains to this here, and Jared wanted to know, do you ever find that APC coatings has transferred to the cylinder wall or valleys, or does it burn off during the mixed lubricants at high temperature, you know, friction-based break-in type deal?
no, we've never seen evidence of that for a couple reasons. It's a thermoset plastic. So we put it on the pistons, we cook it, and it will not melt again. If you raise the temperature, it'll actually decompose, you know, it'll burn before it melts. So it doesn't really smear. Also, you've got oil all over your bore. So, you know, we fight oil like the dogs, trying to get coatings to stick. If you have oil in your crosshatch, it's not going to stick and transfer into there. So, yeah, quick answer, no, we've never seen that occur.
Yeah,
Maybe
and the particles are
initially.
microparticles. And
Right.
Yeah.
if they're going to go through the filtration system, depending on what your level of filtration is, you'll gather them out. If they don't, we could make a case that it might even enhance your oil. The graphite part of it would.
Kind of like almost like an oil additive. I'm just, you know, trying to break it down to more of a simpler explanation. Now, George, he's the one who started asking the question about the break-in, but he also has a follow-up question. If y'all mentioned valve and valve applications, assuming y'all mean ice valves, is it applicable to valve stems for potentially tighter stem, guide clearance, both intake and exhaust, and effect on heat transfer or conductivity?
Yeah, we can put a thin coating on the valve stems. Sometimes we do the thermal barriers around the head of the valve. On the stems, we've done it a handful of times. One time, a guy, I believe it was a V-twin, an old one, he wanted us to build up the valve a lot, and it would run for a few minutes, and it did insulate the heat on the exhaust valve. It kept the heat in the valve, and then it would pinch and they would start to float. So, you know, there's a limit. We can put the real thin stuff on, but on an exhaust valve, you got to be careful because you will start insulating. That's the primary heat transfers through the well, the seat too, but the guide. So we don't want to insulate that.
It's probably important to note that there's variable coatings in this system that we have, and the piston skirt coating is not the same as a coating that you're going to use in an application like that.
Okay,
Right,
well, Woody, since you brought that up, just give us a real, quick outline of what we're referring here to. I mean, how many different coatings do you guys have? I mean, that's what I said earlier when we started this thing at the beginning. I think it might be easier to say what you don't coat more than what you do coat, because it seems like you got something from A to Z. You come to us and say you want to coat it. And when I say this, I'm not talking about just engine related, but there's a lot of other components that, on any kind of piece of equipment, this could benefit. You know what I'm saying?
Yeah, so I should probably take this one. We've got probably 5 or 6 coatings that we've developed, and we've retired some because we found a better one recently, but we start out with the soft abradable coatings. Those are used in blowers when you want to put the thing together really quick, have it break in a matter of seconds, and then have it run for, a couple 100,000 miles like a production setting. Then, but those supercharger coatings, they really don't carry load once the break-in occurs and you go through your whole transient thermal cycle and torque it in. So then if you use that stuff on a high power engine, it won't hold up. So we have a harder version of super soft fuzzy, and then we've got a harder version yet for things like top fuel and over, say, 6,000 horsepower, up to like 5,000-6,000 horsepower, we use Slick Plus. Then we've got bearing coatings now that are thin. They've got a little orange peel texture to them, but they're not really the abradable coating so much. They're more of a load carrying thin solid lubricant, and that's what we would put on something like a valve stem or a bearing itself. So we've got quite a few coatings and a lot of great anecdotal or feedback of how it worked from racers, because when we started with pistons, we went, yeah, isn't this cool? It's great. And the guy goes, yeah, that's really neat. Can you do bearings? And I go, I want to do pistons. But yeah, we've been pulled into so many different even like space devices that are supposed to go to other planets in vacuum pumps. And yeah, we're always trying to find that balance for any application where you can put the thing together, break it in quickly, and then it lasts. It's a lifelong geometric improvement to that component and a lifelong tribological improvement. We don't want it to go away after you run your engine for 10 minutes.
You should click up to the oil pump slides, Andy.
Yeah, we could do that.
And guys, while you're doing that, I want to address Peter Vorm has got a question here. I think it kind of pertains to what area you're in here right at the moment. And he says that he ran an NTN bearing incorporated 3-ball on rod rolling contact fatigue machine for micro-inch coatings. Do you use one? I made many changes to be able to detect film failure. And I think that's what we're kind of addressing here. You guys, there's a certain amount of wear, but do you ever have to go back and recoat, or does it stay pretty much throughout the life of the part?
Well, that's a big question.
Yeah, it's an application specific kind of question. In the case of a piston skirt, a recoat can occur for a couple of different reasons. I'll give you a close up of this if we can see it. This is one of our customers, John Hurd. He runs a 626 big block Chevy nitrous motor. he got this engine apart. He you know how we are as engine builders. We feel something's wrong. He pulls it apart, and he's been picking up debris in the piston skirt. Another little key hidden attribute to these thicker skirt coatings, they are debris tolerant. They could pick up a piece of particulate that came from, you know, cast iron porosities, what have you, or if a part's starting to go away, they save the engine. We can strip this coating off, recoat it, and come back. If you have an application like a spur gear in a oil pump or something along that line, that's a wet environment that's not unlike the dry environment Andy described as the blower. Once it's fit, it's not going to carry any load. You're just taking up the space that they couldn't practically, in a practical fashion, machine and get you, so your pump efficiency is going to come up. And then this is really a key in the street performance engine stuff we do. There's some of the old dinosaur engines like Pontiacs. They're notorious for poor oil pressure. Coat the pump, gears, housing, everything. That low PSI pressure now came up by 10, 15 pounds at idle, just picking up all the inefficiencies out of the pump. And even in newer pumps, the one that's on the screen right now, this is a gear rotor application in a newer high-tech gear rotor application. And as we like to say, everything that's black in that picture is a leak path, and we filled it up with a coating. The shiny stuff is where the gear rotor was actually hitting. So if you go to the next slide, you'll see the gear rotor itself, and you see the shiny spots internally. You see the, you know, that's, if you had to machine that perfectly like that, you'd have a NASA level part, and it would cost NASA level. Well, it's not practical.
Right.
This way you can get that efficiency back in it. So, you know, as far as the wear goes, you know, we wear to a point where they're fit. And that's, so it's a little bit different type of testing that we're doing, and a different application when we talk about wear.
And recoating isn't always generated by wear. On pistons, we can recoat them as long as there's no issues with them. So we had one sprint car engine builder that every season when he'd do his freshen up, he would touch hone his bores, send us the pistons. We could strip them and resize them to the next size that he came to with the coating. So
Good point.
it can be done over and over again.
Yeah, and to address the 3-ball question with the tribological testing, one of the biggest differences between our coatings and most of the solid film lubes, which are very thin, is we create a better uniformly loaded interface between our parts. So if we jump back up to pistons, there's one that was, you can see there's still fuzz over here on the side, but there is some engagement. You can see it's burnished more in the middle, and more fuzz over here. I believe this was a stroker. That's why you see this little line in the middle. But what we're trying to do is create a uniformly loaded oil film. So the drop of oil right in here doesn't know which way to go because there's no pressure gradient. So the other solid film lubes, they work when your oil film fails. There it is to save the day. Our self-fitting process creates such a stable oil film. You know, there's no way. This is a very soft coating. You could scratch this off with your fingernail right now, or you can at least mar it very easily.
Mm-hmm.
If it was touching the bore, it would be gone. The oil film gets so good in some of these applications that it really doesn't touch. You could liken it to if you're on a lake and say you're standing in 4 inches of water and you got a shovel. You swing it at the bottom of the lake, you hit the bottom. Well, if you do it with a snow shovel, you can swing that thing really, really hard and you're not going to hit the bottom in 4 inches of water because it's going to stop. That's what we're creating with the abradable feature. And then, you know, like with the bearing coatings, what we like to see is not much wear, because that's one of these preventative, scuff preventative, maybe free up some lubricant when the oil film fails. but usually we want to see, we do reciprocating testing. We want to see some material come off in the first 1,000 cycles or so. And then your footprint is growing, and you're getting down away from those peaks in the coating to plateaus that are oiled. And then the wear stops. It's like an asymptotic wear decline. So the thin solid film lubricants, we're compared to them all the time, but we're doing a completely different thing. Making parts fit, homogenizing oil film pressures, eliminating the peak oil film pressures. A 3 ball is about the worst you could get. You know, you got 3 peaks carrying all the load. We want to avoid that situation with our coatings. And then, of course, if your oil film does fail, you got graphite and plastic in the way, preventing micro welding. I hope that answers the question. I'd love to chat after.
Well, that's the great thing about it. And I'm glad you brought that up also, Andy, that I think we got a lot of interest right now. A lot of people right now are asking questions, and that's what we wanted, is that you guys are willing to take calls, you know, even after we get off the air.
Sure.
And again, we've already touched bases with Francis and Judy about, you know, if this thing, you know, and you want to do some more and show more about your product, I'm sure we can get you back on. But we still got time to go, and we're going to keep answering questions and trying to make sure that we get everybody all the possible information we possibly can out right at the moment. But so far, I think that, you know, we're definitely piquing some people's interest out there, and it's just trying to keep up with the number of questions we have here. But possible applications. George again is I think we got his wheels are turning pretty big time. And he wanted to know about possible applications inside windish trays or something similar, you know, for oil direction and everything. So did you ever do anything down in that part of it as far as internally?
No.
Crankcase baffling, that type of thing, or?
Yeah. Scavenging, return, stripping, anything like that.
Yeah. No, I think in that kind of an application, I haven't kept up with the coatings that had come out there, like the oil shedding type coatings or whatever. Those might be a better benefit there. I mean, you know, consider that we want to retain oil. That's our main claim. We need to, especially the piston skirt applications in the oil environed applications, I should say, we want to retain the oil and have it there when it's in in the relationship with the bore. So an application like scavenging and crankcase compartmentalizing and things like that, I'd look towards oil shedding type coatings.
All right. What about when you go and do it? Here's the guy talking about an oil pump itself. You know, when you're doing an oil pump, do you need the housing or just the rotor in that application?
Well, we like to do them all. And we've come up with some, you know, there's a lot of folks out there still running spur gear pumps. And unfortunately, those were some of the most inefficient, you know, wet sump oil pumps that were made. We do the top, the housing, and the gears. And we've changed our process over the years now where we actually coat them, get them fitted, rotate them in a partially cured condition, and then clean them all out again, and then refit everything and then bake them out to the final bake so that the customers don't have to, spend a great amount of time trying to fit these pieces together. The gear rotor pumps, they're surprisingly have a lot of inefficiencies. It depends on the pump, from part to part to part. Well, one of the other key things is, I'll go back to, back in those Can-Am days, we used Weaver Brothers dry sump pumps, and the only way we could fix one of those pumps was to send it back to Jerry Weaver and wait. Okay, so, and they were good pumps too. That they sort of led, if you recall those, Jeff. But now, we've fixed, if you please, or put back in service, better stated, these housings for the dry sump segments, redone the gears, and they pick up a lot of debris. And, every one of those lines on the gears, every one of those scratches inside that housing is an inefficiency. And basically we can fill those up, fix it, take up all the gaps, and the pump could be better than OEM in some cases.
Yeah, the
Where
coating
were you
really
back in the
helps.
day when I needed you?
Yeah. Oh boy, I'll
Sorry.
tell you.
I'll tell you right now, I'd hate to think about all the oil pumps I saw going to a dumpster, getting ready to get thrown away to the scrap yard because you couldn't fix them.
Yeah, when you got a shelf full of those dry sump pieces and you're scrounging through there looking for the best one.
Yeah,
Okay.
yeah,
Not a new one, just the best one,
right.
But
That's crazy.
yeah, we have a lot of oil pump stuff we do for folks, and it's still, there's a lot more to do out there, and it's in some cases people think, well, it's a knock on the OEM manufacturers. No, that's not true. These products are excellent products, especially when you consider what they do and at what price they're sold for. It's actually amazing. But can they be made better by through the use of this coating? Absolutely. And it's just one of those, everybody's looking for that little hidden tick. The really good guys out there will go back and think, you know what, if I can get some more efficiency out of here, maybe I can use a thinner gear. If I use a thinner gear, it's going to take less power, et cetera, et cetera. So there's benefits out there to be had.
Well, and we also have been contacted for unobtainium parts. I had a gentleman just call me about his AMC 390, where the housing is built into the timing cover. So the AMCs, Buick 455, Dodge Vipers, where the housings were integrated as a part of the timing cover, we can restore those and put them back into service.
Good point, Mark. And that's that first gen Viper engine from the folks we've been working with at PMD here in the Detroit metro area. That first gen engine, those covers are not made anymore. So we get those through every now and then. We've coated every one that they've had come through their shop. And that basically restores that piece to a point where they can use it again. That engine configuration changed and nobody ever made that casting again. So that's one of those parts and there's a bunch of them out there like that we can actually come back and fix.
Okay, while we're there and we're talking about what you can fix, tell people that are listening here, what is the thickness that you can, apply your coating to be, thickness you can get by with, and what's the maximum thickness, and what is the lightest coating you can put on? I've read it, but you explain it to them.
The thinnest coating we can put on is about, with the Abradable, is about 7/10 of an inch, 7/10,000ths. With the thin bearing coatings, we can put like 4/10,000ths, and that's a smoother coating. So if you don't have room for 7/10ths to a thou, we put it on anyway, and you just Scotch-Brite the top of that fuzz off until it fits, and then you're still left with that nice tribological surface for your running. And then the maximum on the bearing thin stuff, we go up to about a thou. Above that per side, we're going to have to start introducing the powder again to create a buildup. We do that on a lot of vintage stuff. We haven't done it on a lot of high power stuff though. So then on the abradables, we can go up to 500 microns. We can put 20,000ths of coating on a piston skirt. And we've done that in like 4,000 horsepower engines, up to 24,000ths on the diameter, and it worked great. So one of the problems we run into, it's funny you mention it, if you're building an oil pump, you spend your whole life trying to get clearances out, trying to machine absolutely perfectly, and you do run into limits. And then after the guy's done trying to optimize it, we may meet them and we go, yeah, I wish you had 2,000ths of clearance in there, because then the coating could really do its thing. And they just engineered, down to 3/10ths, and then they come and see us. So we like to get in the beginning of the conversation on design, and or on pistons, it's easy. They want to run it, well, open up your bore a couple thou, give us room for the coating to do its thing. other applications aren't so easy to modify. But yeah, there's a wide range, and each formula has its own practical limitations. We can also do layers. We can put a really strong coating, build it up 25 thousandths, and then put 4 thousandths of fuzz on the top. So it breaks in real quick, but you've got a really strong base.
In the pistons, as far as pistons goes, this is one where size doesn't matter. We've done really small diameter Maytag gasoline antique washing machine engine pistons, and we're doing a locomotive piston right now that's about this big around. So we do everything in between.
Well, we keep focusing on engine components and performance, but in the restoration world, I had a customer with a 1912 Pope Hartford, where his machinist had cut the valve cages too big. So we put on 30 thousandths of our hardest coating on the diameter, and he put it on a lathe and turned it down, installed them, and said that it worked perfectly. So we do have people come to us with some unique ideas that we may be able to cure using APC.
Yeah, we've done trunnions on suspensions. We've done torque tubes on dirt track cars. Lots of places, if we can get it in our oven, we'll try it. If you think we can solve a problem for you, we will certainly do our best, and look forward to your feedback. So one thing I wanted to touch on real quickly, because we're running out of time, is this range of coatings works really well in development or in racing, production, or restoration. In the development world, you put things together, you start to see where they're hitting, where there's room, where it's loose, witness marks. You see a lot of what's going on before you destroy your components. You can run it for a short time, look at the coating wear, and go, wow, that's what's happening. Then in race, of course, you might pop a coolant plug out and run 2 more laps on your dirt car with no coolant and still survive. You can lose oil pressure for a little bit and live. Production is really where we started, and we want to reach out to the businesses out there, like the gentleman with the three ball test. He's probably not in his garage with that, but it provides a robust way in a factory to put these things together every day, all day. You've got tolerances and stack ups and bearings, everything's changing, and this product makes it easier to get it perfect every time with all that random variables coming into your factory. And then in restoration, that's really fun. Grandpa's old thing won't run, and we'll try it. We can make that shaft bigger. We'll make this piston bigger. We'll clean that up. And, then we'll cross our fingers and hope the thing's really happy when it's running. So, we have a lot of fun with working with people.
Well, that's a very positive thought and a very, I think, great way to kind of wrap up this particular webinar. Guys, it's been a pleasure. And like I said in the very beginning, remember, A to Z. You got to figure out which one you need and come see you guys, and you'll probably figure out a way to help it, because I'm sitting there, got my head spinning. I got some, my daddy was a big Model A collector, and we got a few things that I could probably get built up on. It would help me in a restoration kind of position on a Model A Ford. So
yeah, we've done Model A pistons.
Yeah, Model A pistons, exactly right. Exactly what we need to do. But all the folks that have been tuning in, from Peter, who said, hey, I'm a retired materials manufacturing lab guy from Wright Pratt Engineering. And he says, we've had 300,000 PSI load on bearings and jet engines. And you say you're doing stuff for the aeronautic world. And, Donnie, sorry, didn't get a chance to talk a little more about your stuff, but at the same time, give these guys a call and, line to line. And I've been want to bet you they can come up with a solution.
Well, and I did want to just point out very quickly that we've got several different locations where you can get your parts coated by us. Our headquarters is here in the Metro Detroit area. We've got a coating satellite over in South Carolina that's run by Brian, and we've got one over in Nevada, run by Chris. So there are several different options on where to send your parts.
Isn't there one coming down under?
That is true. We're getting ready to launch in Australia, and we're very excited about that.
Well, thank you so much, gentlemen. I don't think we touched anywhere as close as the amount of slides you had prepared, Andy, because we had a little rehearsal on Monday and there was a lot of, so we should talk offline and invite you for a part 2, because I know there's a lot of stuff you wanted to talk about, and we're so happy to have you on, and you have so much to share. So we'll invite you back for a part 2 if you want to do it, and so we can go through all these slides, because there's like probably 40 pages in there, and I think I just saw a few today. So thank you very much for being with us today. This webinar has been recorded. It will be distributed later on the Portrait platform, as well as on our YouTube channel and different social media channel. We push Line to Line's product back on the homepage of ePortrait. So please go to www.eportrait.com for more information and updates. We will be back next week with Get Them Garage at 9 o'clock Pacific on Wednesday. Thank you very much, and bye-bye.
Thank you.
Bye.
Thank you. Bye now.
ePortrait is a digital platform that we've created basically to make life easier in the business community of auto racing.
ePortrait, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, all you need to do is click on request more information, and then from there it is forwarded directly to the buyer or to the supplier.
ePortrait really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
With roots in the Midwest that date back well before the Model T, Fifth Third Bank has a long history of serving the needs of automotive companies. While much has changed over the years, our passion for helping businesses put cars on the road and on the track has not. Today, we are more committed than ever as a member of SEMA, a founding member of PRI, and a sponsor of multiple race teams across several racing series.
For over a decade, Fifth Third Bank has been a staunch supporter of our industry and a great partner for many companies in the motorsports field.
Our business has been growing extremely fast, and really we could not be where we are today without Fifth Third. They provided amazing strategic advice, the capital we need to support our phases of growth.
They are true partners for me now, and what they do with their involvement in motorsports is untouched in this community.
Where can we take your business? Fifth Third Bank.
Where will you find Ferrea racing components? Circle track, drag racing, and any top race shop. In every form of motorsports competition, our valves and valve train components deliver race-proven design and technology. And we've brought that same performance to our street applications as well. We're backed by 5 decades of experience, an extensive range of off-the-shelf components, and our custom valve department has the fastest turnaround times in the industry. Ferrea Racing Components. Stand with us or race against us.